Hello again, we're doing another Space Invaders board for a customer. So they've made it's obviously had a Tato board in, and then they've ended up with a Midway board because they've made this harness adapter which sits on the top, and they've soldered it into the back of these pins here, which normally get these connectors, which are for Midway type board. So we're trying to figure out what if I have the regular CPU, which is that, in the socket. I'm going to put it in that little tray for safety. If I have the CPU in its socket and run it, you will get the game to run. I've got the float pod in there because what it does is it just keeps sticking and resetting, and the coin counter tries to run up and all those sorts of things. If I try to do a memory test, I get an error. So I'll try to do a RAM 2000 to 3FFF, which is the RAM region. You get BTS0C. However, if I press the bus test button, I get this CTL error. I've never seen one of those before. I'm going to have to look at what the hell that is. I've got the Fluke manual here for the 9010A. Let's have a read and see what we can find. A little digging in the manual, and we find the exact error. It says the bus test exercises the control lines and identifies any that are not drivable by the interface pod. The control lines tested include lines that the operator can explicitly write to, as well as lines the operator cannot explicitly write to, such as timing or handshake lines. Any line where the value written by the interface pod does not equal the value measured by the interface pod at the micro P socket is reported as not drivable. An example of a message that might get received back with an 8080 micro system is the following. Well, we're using 8080. CTL error. No, blah, 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 blah. Loop, which is exactly what I've got, kind of what I've got. This message indicates that control line corresponds to bit 4 is not drivable. If the operator loops on the error and removes the error, the message changes to the following CTL OK. So that example there shows bit 4. So bit 0, 1, 2, 3, 4, correct? And on here what we've got is 0, 1, 2. So we've got bit 2. Now, I don't know what control line bit 2 is, so I'm going to have to look that up. Okay, so I've found the 8080 pod manual and skipped to the end basically for everybody. And what it says is bit assignment control lines, and it's talking about HLDA weight and INTE, which are pins of the CPU, but it cannot read or write or drive or something like that. And what it explains is that basically is that if you've got one of these bit patterns, it corresponds to a particular state. In our case, 100, which is what we're seeing there, going back over here, 100 there means writes INTE high, HLDA, and weight low. If any control line cannot be driven, the troubleshooter responds with the message CTL error at, and then gives a bit mask where X equals a binary 1 if that line is not drivable. So, in that case, the INTE, it's the INTE line that we're interested in. Okay, so the INTE line, now let's see if I can find it, because on the back of the interface pods, there's this useful little thing here, which gives a memory map. So I'm going to guess that INTE, pin 16, is the one that we're interested in. Now, what I'll need to do now is get the schematic for the Midway boards, which is what this is, and find out where pin 16 goes to. So it sounds to me like there's a chip hanging off pin 16, which is stuck. Alright, so let's find that and clear that error, and hopefully, if we can clear that error, we can do a RAM write, and then we can run the program, because if that is sticking, I would imagine that that's half the problem. Right, now we're getting somewhere. So I have the schematic here for Midway boards, and we find the INTE here. It's very difficult to read. There's your reset pin. There's your HLDA and your weight. So DB in there, 16. INTE comes all the way down here and goes to the edge connector, which is here, to pin H. Now, I've had a look. I was thinking, does the top board have anything to do with this? Now, pin H is only about 6-7 pins in. If I go to there and hold it up to light, there's absolutely nothing connected to pin H, which is 7 pins in. 1, 2, 3, 4, 5, 6, 7. Absolutely nothing connected there whatsoever. So that signal is not being, even though it's going to that edge connector, Midway designed it to go to there. They obviously never decided to implement it to, unless that's a test, a way that they could stick a test card in there or something like that for debugging purposes. That would be about the only thing I could think of. Or maybe if you tip the board on its back, you'd have a probe point directly onto that. So the INTE pin goes to this S74 chip here, E5, and it only goes there. So what I'm suggesting is that potentially that pin there is stuck, because the output of it, if I just zoom the schematic slightly, get it back into things. So S5, hang on, control that, here we go. So it's using one of the outputs, and the output goes up to, let's follow the output, shall we? So pin 5 output there goes all the way up that line, goes along that junction there and into the int pin. So it would tell me then that it's not driving the interrupt correctly, which would make sense. Int external, int input. So if it can't drive it, because the only thing that it's connected to is that pin 2, that pin 2 must potentially be stuck low, or that chip is not outputting a signal, which basically means when it tries to drive it, it's not doing anything. Let's reconnect the board up, get the scope attached to pins 2 and pins 5 and see what's going on when we try to do a loop. Okay, so you can hear that beeping away in the background. Okay, I apologise for the horrible noise. I can't do anything about it until I can show you this. So it's actually E3, which is this. So E1, 2, 3. Here is pin 2 of E3, which is that one. I think I've got that correct. Let me just double check where I am on the board. It says, sorry, E1, 2, 3. Yes, that's that chip there. Very difficult for me to do with the camera. So there's the CPU sending it a signal to there, and the output to the 3. I hope I've got this right. Is that 7474? No. There we go. There's 3. Sorry, putting the wrong pins. There's your pin 2. So there's the CPU trying to drive that line. Okay, pin 3 and 4 and then pin 5, which is your output. And you see there, it's just stuck high. So the pin 5 is doing absolutely nothing. But if I go to pin 6, you can see that's trying to pull low, because that's the inverted version of pin 5. We're going to stick another chip up, we'll stick a 74 over the top of that and see what happens. Well, would you Adam believe it? Sticking that 7474 over the top of E3 there, it's caused the game to run. And it's not endlessly coining up. If I put a coin onto it, I think that's the one. Credits. Have I got my coin switch hooked up? I don't know if I've got coin connected correctly on this loom. I may not have. That might be part of the problem. I will trace it back and find out. And if I haven't, I will add coin, because this loom that I've got here was actually intended for a regular jammer rig. Have I got coin? Sorry for throwing the camera around a bit. Coin switch 1 on the top would be coin SW1 is pin 16. So did I wire up? I'll just position that there. Coin SW1. No, I haven't actually, or at least I can't. Oh yeah, maybe I have. Maybe it's that green one. Coin SW1, I think is that green one, because there's your video ground. 14, 15, 16. So coin SW1 is supposed to come up to that. I'm certain that's coming to there. We'll do some further debugging, but the main thing is the game now, at that point, is booting up. Now it might be that until I change the chip completely, that I've still got problems, and that's why it can't coin up. I'm going to test it with the scope probe and just see if it changes high-low, and then I'll change the chip, and then we'll see where we are at that point. And if we clear another coin input issue, then so be it. Okay, so on a little bit further investigation, what I find out is actually I've only got start SW1 hooked up on there, not coin SW1. The green one there is actually pin 17. Pin 17 on the jammer rig. Pin 17 is start SW1, so I didn't wire up coin, so I will do. I'm going to wire up coin now from that to wherever it goes on one of these two connectors, and then make sure that I mean, I can actually just ground it out. That would, yeah, let's see if we can just ground it and make it work. Which one is coin 1? Let's go back to this site here and get the pin out. Midway, Space Invaders pinouts. Pin out, here we go. Where's the coin? Coin. That's coin meter. Coin is pin 3 on the 11 to 14 connector. So we've got ground. Where's the key? Key's at 7. So you just have to know which way round you're going. So pin 3. We don't have a pin 3 on there. So what I'll do is I'll take the thing off the end. Sorry, just put you down just for a second. Apologise. So I can take it off the end of the scope probe. Right, okay, so I've got a ground clip. Pin 1, pin 2, pin 3. If I do it correctly, if it is grounded properly, pin 3, that one. Nope, it didn't ground, so this is not obviously a proper true logic ground. Let me find a logic ground. Where's a logic ground? Logic ground. So I've got a logic ground on that one. Or where am I going to find a logic ground? Ah, ground. So if I clip to what is effectively exactly ground there, and then go to here, and go and touch that one, yeah, we get Play Space Invaders. Exactly as we expect. So I'm going to stick a couple of credits on it. 2, 3, 4, 5, 6, 7, and it's not increasing. Which the problem it actually came here for was the fact that the counter was going up like mad. Sometimes when I press this, I will get multiple credits because it's just the way that it doesn't I'm not debouncing it, which is I'm not providing some kind of resist to it. If I press start now, so I've got sound. I don't seem to have the march sound, but I seem to have everything else. Well, what I'll do to test the sounds is I'll stick my braze board on it into the CPU socket. I'm going to change this chip. I'll stick the braze board into the socket and I'll see what happens when if I can get myself killed. Yeah, there's the saucer sound. That's the usual pain in the arse one. Come on, kill me. How do you go? There you go, so I'm dead. Okay, that's a good sign. So the only thing I don't seem to have is the march sound on it. It might be there, it might just be very, very quiet. Well, there's all the rest of them. Anyway, we'll find out via the braze kit. I had a little bit of a scare for whatever reason after I changed the 7474 chip out. For some reason the board would not come up with a full decent picture again. So anyway, I fixed that. It turned out to be it was really weird. It turned out to be my edge connector here, not the board. The keying is just the size of this connector and the size of this is just a fraction off from one another, so it's easy to get the pins very, very slightly misaligned on it, and that was causing the 5 volts to trip out and just partially ground out. Anyway, all fixed. What I've got now is I've got the sound test going, which you get in the braze board. So if I go back to there, saucer sounds fine. Missile shot, explosion, invader hit, tone, and then I get, this is what I'm having. Aha! They work now. They weren't working before. I could make a tune out of this. Oh well. That's very, very interesting. Because a minute ago, they definitely were not working for me before I started trying to record again. In that case then, how do we get out of here? There we go, reset. Board's all in place. Maybe reseating it. Maybe, I don't know. Don't know what I've done to restore that. Anyway, fire to continue. We're on that version of it. Press start because it's on free play. And we should get the invader thump thing. Here we go. All sounds present. Now, Andy from Arcade Club always does it about the Midway board sounds being slightly different. And they are. I don't know whether that's the... I don't know what that is. definitely the sounds are slightly different between the Midway board and the Tato board. Oh well, potato board. So couldn't resist that one. Everybody always says the same thing. Well, there's another Space Invaders repaired. I'm going to put it back in the cab later on this afternoon and see where. Just make sure that the credit board and everything works. But I'm pretty certain that the reason that the customer reported that the credits just kept cycling upwards and upwards and upwards like crazy, I'm pretty convinced that the reason that that was happening was because of this stuck interrupt section here. I'll write the whole repair up in our log database and everything. But ultimately, I believe that one's probably fixed now. Woohoo! Can't make my mind up whether to spend the time and resort his cabling out. It works. I think we'll just leave it, to be honest. So, well, that one can go back in the game, and then I can return the two machines to the customer. Might do a little bit of follow-up video. Yeah, I'll pop them back in. I'll show you. I'll show you it working in the cab. Alright, this is nothing about Zookeeper, but I just thought I'd stick the machine on for 10 minutes and have a break before I did anything else. Right, so the Space Invaders board is out here, in this machine here. There we go. This machine seems to be missing its cardboard background, but I press that, it's no longer doing all its stuff that it was doing, and it makes all its sound. Hard to play one-handed, but there we are, Spaceys. My mates from the other course will say, Spaceys. Anyway, there we are. Another one repaired, all in its cabinet, ready to go back to the customer. The only thing I've got to do now is print a key tag up for it because they sent me all the keys and they just need pairing up properly. Lovely machine, in decent condition as well, this one. Normally they're a hell of a lot more battered than what that is, but you know, hey, there we are. Tato Space Invaders.